Alright, so this is the practice test, part 1. I don't know if it's the easier part, but we'll just jump into it. Problem 1 is super easy. There's not multiple ways it can be done. Problem 1, I'm just going to take the derivative of each term. The first term, 3x squared, I'm going to multiply the 2 by 3 and get 6. I'm going to lower the exponent by 1 and get a 6x to the first. The middle term is a first power term, so the derivative doesn't have the variable, just the number in front of the variables or the letter is the derivative of it. So the derivative of minus 5x is just minus 5. The derivative of 4 is 0, and that's all there is to do for part 1. Question 2, it's a fraction, so if you want to, you could use the quotient rule to take the derivative. There's two ways. There's a way to do it by rewriting with a negative exponent. And this avoids the quotient rule. It's the easier way to do the derivative. Some students don't like that method, and they prefer the quotient rule. Anytime we have a fraction, we're allowed to use the quotient rule. Some fractions are special, like in problem 2. I could actually do this problem without and avoid the quotient rule. So I'm going to do it both ways. You pick the way that you like. For the first method, I could bring the x to the squared kind of up from the denominator. I'd probably just write it as to the right of a fraction with a negative exponent. I could have actually put that in the numerator as well. But that x squared, I can dig it out of the denominator and either put it in the numerator or put it next to the fraction. And now I can do the derivative by just taking the exponent of negative 2, multiplying it by the coefficient of negative 3/4, and then lower the exponent by 1. Negative 2 minus 1 is negative 3. Now I'm going to cancel this negative 2 with the positive 4. Negative 2 divided by 2 is negative 1. 4 divided by 2 is 2. I'm going to multiply the negative 1 and negative 3 and get positive 3. I'm going to leave the 2 that's left in the denominator. And then I'm going to do the opposite of what I did on the first part to make the negative exponent back into a positive exponent. I'm just going to bring the x down into the denominator. Hope this isn't blurry. It just looks so blurry when I'm looking at it. Maybe my monitor's just not doing well this morning. That's probably the better way to do it. The other way is to use the quotient rule. Remember, the quotient rule is denominator times derivative of the numerator minus numerator times derivative of the denominator all over the denominator squared. And the hard part of this is squaring the denominator properly. So if I want to use the quotient rule, the denominator is 4x squared. The numerator in the original function is negative 3. The derivative of the denom is 8x, and the derivative of the num, since it doesn't have a letter, is 0. So if I want to write the derivative down, I'd write f prime of x equals to denominator 4x squared times derivative of the numerator 0 minus numerator negative 3 times derivative of the denominator 8x all over the denominator squared. In the numerator, this piece turns into a 0. This piece is negative 3 times 8x. The double negative turns positive. I'm left with a 24x. And in the denominator, this 4x squared, I forgot a square here. It's 4x squared, all squared. In the denominator, this is 4 squared and x squared squared to square it. Squaring the 4, you get 16. Squaring the x squared, you multiply the exponents and get x to the 4th. Now I'm going to reduce the fraction 24 over 16. 24 divided by 16. Math, enter, enter. The fraction reduces to 3/2. And I'm going to subtract the exponents on the x's. The exponent in the numerator is 1. The exponent in the denominator is 4. 4 minus 1 is 3. And the x will wind up in the denominator because that's where the larger exponent is. And that's the 2 ways to do problem 2. For problem 3, I need to make the radical go away and make it have a fraction exponent. I take a radical and turn it into a fraction exponent by taking the index and putting it under any exponent under the radical. So rewrite with a fraction exponent is the first step. That's not taking the derivative. Taking the derivative is multiplying the exponent by the coefficient and lowering the exponent by 1. So I'm not going to write the little prime symbol. I'm going to leave the 2 where it's at, and the radical sign is going to go away. That 3 is going to turn into a denominator of a fraction under the original exponent. Now I need to subtract 1 from the exponent and divide by the new exponent. That's taking the derivative. So I'm going to multiply the exponent 2/3 by the coefficient 2, and I'm going to subtract 1 from the exponent. If I'm doing it on my calculator, I would just go 2 divided by 3 minus 1 and go math, enter, enter, and get negative 1/3. If I was subtracting 1 and I wasn't using my calculator, then instead of going 2/3 minus 1, I'd write a fraction equivalent of 1 that has a 3 in the denominator, and 2/3 minus 3/3 is also negative 1/3. Now I just need to clean this up. When I multiply a fraction by an integer, I just multiply the numerator by that integer. So 2/3 times 2 is 4/3. The original problem didn't have negative exponents, it actually had a radical, and I'm going to get the problem back in radical form. To get the problem back in radical form, I'm going to make the negative exponent that came up positive, and then I'm going to create a radical. This piece right here is going to be the radical part. It's going to turn into a radical, and the 4/3 is just going to hang around but not going to be impacted by the radical. When you have a fraction exponent, the denominator, and you're turning it into a radical, the denominator becomes the index and the rest goes under the radical. So for this x to the 1/3, the 3 part becomes the index and the other part goes under the radical. I don't need to write an exponent of 1, and probably the best answer for problem 3 is the derivative is 4 over 3 cubed root of x. I think that's probably a nice way to say it. 4 is a fraction. I could also use the quotient rule for 4. Just like I did a rewrite for number 2, I could also do a rewrite for number 4. It turns out that on the test, most students just want to use the quotient rule. But there's 2 ways to do this problem because the denominator just has a monomial. So I can avoid the quotient rule by doing a rewrite first. And the rewrite that's necessary for this one is to separately write each term over the denominator. The first numerator, the first piece, the x squareds cancel, and I just get 5. The second piece, I'm going to make the fraction into something that has a negative exponent. So that's 2 steps to rewrite this problem, and now I can avoid the quotient rule. Now I can write the derivative symbol and actually take the derivative. First piece has a derivative of 0 because it's a constant. The second piece, I'm going to multiply the negative 2 times 3 and get negative 6. Lower the exponent by 1 and get negative 3. And now I'm going to make the negative exponent positive by creating a fraction that has that term, that negative exponent, buried down in the denominator. I think that's the better way to do this, but the alternate way is to use the quotient rule. You don't have to do both ways, just whichever way you like better. If I was finding the derivative of this using the quotient rule, I'd have to say the numerator, I do the denominator first. The denominator is x squared. The numerator is 5x squared plus 3. The derivative of the denominator is going to be 2x. The derivative of the numerator is going to just be 10x. That 5x squared has a derivative of 10x. That 3 has a derivative of 0. And then if I was using the quotient rule to find the derivative, remember it's denom times derivative of the num minus num times derivative of denom all over the denom squared. So for this one, f prime of x is going to be the denominator x squared times the derivative of the numerator 5x squared plus 3 minus the numerator, derivative of the numerator is 10x here. Duh. Denominator x squared, derivative of the numerator 10x. So this should be x squared times 10x minus the numerator 5x squared plus 3 times the derivative of the denominator, and I'm going to slip it over on this side as opposed to on that side. So for the derivative of the denominator, I'm going to put a 2x here, all over the denominator squared, which is going to be x squared all squared. Now I'm going to multiply x squared times 10x by taking 2x's and multiplying it by 1x and getting x cubed, preceded by a 10. Clear this, I'm going to go 2x times 5x squared. I'm going to go minus 2 times 5 is minus 10. X times x squared is x cubed. And then minus 2x times positive 3 is minus 6x. The denominator, you multiply the exponents and get an x to the 4th. Now on the numerator, the 10x cubes are going to cancel. I'm left with the derivative equals to minus 6x over x to the 4th. The x in the numerator has an implied exponent of 1. I'm going to simplify by subtracting the exponents. 4 minus 1 is 3, and I leave the x where the bigger exponent is, which is in the denominator. If you look at the avoiding the quotient rule, using the quotient rule, the derivative comes out spot on, exactly the same. So if you don't want to try to avoid the quotient rule, if you want to just blindly use the quotient rule for the derivative of every fraction, it will work every time. It's just sometimes you can avoid it and it saves some work. Similarly, problem 5, it's set up for the product rule because there's multiplication. This is easy multiplication to get rid of. So I can either FOIL and avoid, avoid the product rule, or not FOIL and use the product rule. They come out exactly the same in terms of the answer. So let me do the foiling first. So if I was foiling this to get rid of the parentheses. First would be x squared times 3x, which is 3x cubed. Outers would be x squared times minus 1, which is minus 1x squared. Inners would be 6x times 3x, which is plus 18x squared. And lasts are 6x times minus 1, which is minus 6x. If I combine the middle terms, the numbers in front of the letters have opposite signs, so I subtract them and take the sign of the larger. That's what I would get if I FOILed it. I haven't taken the derivative yet, I've just rewritten it to avoid the product rule. Now I'm going to take the derivative. First piece, I'm going to go 3 times 3 and get 9, lower the exponent by 1. Second piece, I'm going to go 2 times 17 is 34, lower the exponent by 1. Last piece is the first power term, the derivative's just the number in front of the x. I doubt that that factors. Let me see if it does. So program quad 9, enter 34, enter negative 6, enter. That's decimal, so it's prime. That's the way I would do this problem. But if you didn't want to do the multiplying, then you can use the product rule. The product rule, you need the first factor. That's x squared plus 6x. You need the second factor, 3x minus 1. You need the derivative of the first factor. The derivative of x squared is 2x. The derivative of 6x is 6. And the derivative of the second is just 3. Then if I was using the product rule, I'd say f prime of x equals 2, and I just kind of cross multiply-ish. First factor, which is x squared plus 6x, times the derivative of the second, I'm going to write it backwards like I do a lot, plus second factor 3x minus 1, times the derivative of the first, which is 2x plus 6. I hope when I simplify it, it comes out to be exactly that. First parentheses, I'm going to clear by going 3 times x squared, which is 3x squared, 3 times 6x, which is plus 18x. Next bit, I'm going to FOIL. I'm going to go 3x times 2x is 6x squared. I can already see my 9x squared. This 3x squared and 6x squared right there is going to give me the 9x squared. My outers are 3x times 6, which is 18x. My inners are minus 1 times 2x, which is minus 2x. My lasts are minus 1 times 6, which is minus 6. So there's already the minus 6 part. And to get the 34x, it's this 18x, that 18x, and minus 2x. It's 18 plus 18 minus 2. And that gives me 34 for in front of the x. So exactly the same answer if you use the avoiding the product rule, FOIL first and do just a general power rule, or leave it multiplied and do the product rule. If you simplify both of them, they'll simplify the same way. The rest of the problems on the review, there isn't a way to avoid the rules that we might want to avoid. 6, I can't avoid the quotient rule. It's a fraction, but there's a binomial in the denominator. So I'm going to use the quotient rule. I'm going to say the denominator is 3y minus 5. The numerator is y squared. The derivative of the denominator is just 3. The first term is the first power term. The derivative is the number in front of the letter. Second term is a constant. It has a derivative of 0. And the derivative of the numerator is 2y. Now I'm going to write my derivative symbol. Cross multiply that way. I get the denominator 3y minus 5 times the derivative of the numerator, which I'm going to write to the left of the parentheses that I put instead of right, and then minus numerator y squared times the derivative of the denominator 3, and I'm going to write that backwards too. So I cross multiply this way first, that way second, all over the denominator squared. illegal to cancel these 3y minus 5s. Now I'm going to clear the parentheses in the numerator by multiplying 2y times 3y and getting a 6y squared, 2y times minus 5 and getting a minus 10y, and then the minus 3y squared, all over 3y minus 5 quantity squared. I'm going to combine those in the numerator to a positive 3y squared. Still can't cancel because a 3y minus 5 can only cancel with another 3y minus 5. And then I notice in the numerator there's a common factor of a y. And probably the best answer would have that common factor written in the numerator. I'd call that the best answer. If you didn't catch the common factoring, it would be fine. 7's a parentheses with an exponent, so it's a chain rule. Remember, the chain rule is going to be the coefficient times the exponent times the derivative of the inside of the parentheses times the parentheses with the exponent minus 1. So I'm going to write down the coefficient. I probably could have flip-flopped these, but it doesn't matter. When I go to write the derivative, these first three pieces, you can shuffle the order around. I probably should have said exponent first, but since I didn't, I won't write it first. The coefficient is 2. The exponent is 5. Now I'm going to write the derivative of both terms inside the parentheses. The derivative of 4t, it's a first power term. The derivative of it is just 4. The derivative of the minus 3 is 0. And then I'm going to write the parentheses down and lower the exponent by 1. The exponent was 5. I lower it to 4. I don't change the contents of the parentheses. Now I'm just going to multiply these three numbers to the left of the parentheses, and those multiply out to be 40. And I'm done. I'm not allowed to multiply that 40 inside the parentheses because that would be doing multiplication before exponents. Eight is multiplication. Both factors have an x, so I need to use the product rule. So I need to have the first factor which is 4x cubed. The second factor, which is 5x plus 3 squared. The derivative of the first is just 4 times 3, which is 12, and lower the exponent by 1. So 12x squared for the derivative of the first. For the derivative of the second, I need the product rule, or the chain rule, because it's the parentheses with an exponent. So I'm going to do coefficient. The coefficient's an implied 1. There's an implied 1 there. So it's coefficient times the exponent times the derivative of the inside. The derivative of 5x is 5. The derivative of 3 is 0. Times the parentheses with the exponent lowered by 1. So this is going to give me 10 times 5x plus 3. Usually I like things factored. So let me leave it factored. So now I'm going to use the product rule. I'm going to multiply, put a plus sign between for my derivative. So y prime is first factor, 4x cubed, times derivative of the second factor, times 10 times 5x plus 3, plus, I probably could have written that backwards, it probably would have been better, times second factor, I'm just going to say 5x plus 3 squared, times the derivative of the first, which is 12x squared. Now I'm going to start common factoring factor out. Between this 4 and that 12, there's a common factor of a 4. If I would have multiplied these and got a 40, I could have pulled out a common factor of 4 between the 40 and the 12. But anyways, 4 is all I can pull out. I can't pull out something from both the 4 and the 10 because these are all joined together in one big factor in some sense, or one big term. So I'm going to pull the common factor of a 4, and between this single x to the third power and that single x to the second power, I need the smaller of the exponents, which is an x squared. And between this 5x plus 3 to the first and that 5x plus 3, I need a 5x plus 3 to the first. So that's my common factor. I'm going to leave this plus sign between. To the left of the plus sign, I factored out that 4. There were 3 x's. I factored out 2 of them. I'm left with 1x. I didn't do anything with that 10, so I'm going to leave that 10, but I factored out this 5x plus 3 in its entirety. After the plus sign, there were 2 5x plus 3's. I factored out one of them, so I'm left with 1 5x plus 3. From this 12, I factored out a 4, so it's going to turn into a 3 when I divide that 12 by 4. And I'm going to write the 3 to the left of the parentheses. It'll make the next step easier. And I factored out this entire x squared. So that 12 turns into a 3 when you do the common factoring. Now, inside this second parentheses, if I do the multiplication of 3 times 5x and 3 times 3, I'll make it so I can get that second parentheses simplified nicely. That second parentheses is going to turn into 25x plus 9. That's a fully factored complete derivative. So just 2 more problems, both finding equations of lines. Question 9 gives me a function and a value of x. This value of x is an x coordinate of an implied point that I'm going to need at some point. The function is going to be what I use to get the y coordinate of the point when I go to do part B, but I'm going to start with part A. Part A wants me to find a slope of a tangent line at the value of x that's given. To do part A, I'm going to find the derivative, then plug -2 in for x, and this will give me a slope. That I want. Part A wants me to find a slope of a tangent line. To find slopes of tangent lines, you need to find derivatives. The derivative of the first of this function, the derivative of x squared is just 2x. The derivative of 3x is just 3. And now I'm going to take the -2, plug it in for x, and get my answer to part A. So to find the slope of a tangent line when you're given a function and a value for x, you simply take the derivative, plug that value of x into the function. My answer to part A is going to be m equal to -1. For part B, I'm asked to find an equation of a line. I know that the slope of my line is going to be -1. I know the x coordinate of my point is going to be -2. And in order to get an equation for a line, I need a slope and a point. I need to find the y coordinate of the point. So to get started, I'm going to find the y coordinate. And I find the y coordinate by using the original function and not the derivative. So the original function that's given to me, if I plug -2 in for the x's into the original function, it's going to give me the y coordinate. I think it's an unfortunate -2, but I'll live with it. It's -2 squared plus 3 times -2. Just plugging -2 into the original functions for x's, whatever that simplifies to is the y coordinate of the point. So the y coordinate of my point is -2. So to do part B, I took the x coordinate that was given, made it the x coordinate of my point. I took the answer for part A, which is the slope, I use the original function to find the y-coordinate of the point. And now for 9b, I'm just going to go y minus y1 equals m times x minus x1. In for the y1, I'm going to plug that orange -2. It's the y-coordinate of the point. And in for the m, I'm going to plug in -1. And in for the x1, I'm going to plug in this blue -2. I've got a couple double negatives going on there, so I put them in parentheses. On the left-hand side, that double negative, I would probably not write as a double negative. I'd write it as a positive without showing the double negative. Similarly, on both sides, I'd make the double negative positives without writing the line above it. I'm going to clear the parentheses that I put in by going -1 times x is -1x. -1 times 2 is -2. I'm going to solve for y by minusing 2 from both sides. On the left-hand side, the -2's cancel. I'm left with the y. On the right-hand side, both the numbers are negative. I'll add them and keep them negative. This is a completely good answer for 9b, but you don't need to write the 1 with the x if you don't want to. Writing -x minus 4 is equally correct as writing -1x minus 4. All right, one more problem for this part, and it's finding a horizontal tangent line. We did a handful of these in this section. I know I just did a bunch of videos. I remember doing like a bunch of these. So part A, to find the value of x where the tangent line is horizontal, you're going to find f prime of x, set it equal to 0, and solve for x. So for 10a, I'm going to find the derivative. The derivative of x squared is 2x. The derivative of 8x is 8. The derivative of minus 4 is 0. After I find the derivative, I'm going to set it equal to 0. Solve for x. And get x equal to -4, which has nothing to do with that -4. Just coincident that it comes out to the same number. So that's the value of x where the tangent line is horizontal as opposed to slanted in some way. For 10b, I need a point and a slope because I'm finding an equation for a line. And anytime I'm trying to find an equation for a line, I need both a point and a slope. Usually, I take the x coordinate of the point and plug it into the derivative to get my slope, and I could do that here. I could go m equals 2 times -4 plus 8, which is -8 plus 8, which is 0. I could do that. You can always take the x coordinate of a point, plug it into the derivative. It gives you the slope of the tangent line. Or I could have used the fact that because the tangent line is horizontal, horizontal lines have 0 slopes. The slope is 0 one way or another. The slope is 0 because the tangent line is horizontal and horizontal lines have 0 slopes. The slope is 0 because if you take the x coordinate of the point and plug it into the derivative, you get 0 as well. So I have half of a point and a full slope. I need to get the y coordinate of the point. To get the y coordinate of the point, you use the original function, so I'm going to go f of -4 equals to -4 squared plus 8 times -4 minus 4. Do that on my calculator. So -4 squared plus 8 times -4 minus 4. I get -20 for the y coordinate, assuming I didn't make any dreadful mistake. So now I have a full point. I'm going to now use the y minus y1 equals m times x minus x1. You can shortcut this because when the slope is 0, the answer is shortcuttable. But if I want to, I would just go y minus the y coordinate of the point equals 0 times x minus the x coordinate of the point. The right-hand side comes out to y plus 20. Left-hand side comes out to y plus 20. The right-hand side comes out to 0 because 0 times that quantity is equal to 0. And now I just minus 20 from both sides and get my answer for part B as y equal to -20. My video is getting ready to hiccup, so I'm going to just stop right now and call it done with part 1 of our practice test.